It needs first a prime mover. A prime mover in the sense that it needs to take energy, electrical energy, so that ultimately we can drive it from a PV source and then convert it into mechanical energy so that the shaft of the motor can drive a pump to lift water from a lower level to a higher level. So that is the objective. So we need a motor which can drive a pump. So I will use a symbolic notation for the pump like this. There are various types of pumps, so I will just indicate, let us say we use a centrifugal pump. You have the dynamic pumps. Centrifugal pump comes under the class of dynamic pumps. You also have the positive displacement pumps. Reciprocating pump comes under the class of positive displacement pumps. So this pump will have an inlet. It will take water from the underground sump or at lower level, and you have this this is called the suction pipe. Then you also have a delivery pipe where it delivers the water to a height, to an overhead tank. So you can probably have an overhead tank like this. So in most homes, the water is collected in an underground sump, and the water is lifted from this underground sump and then goes through the centrifugal pump. And most of the homes have centrifugal pumps. There is a pressure difference created between the inlet and the outlet, which pushes the water up through the delivery pipe and then into the overhead tank. So this is normally how the pump systems are set up, and this is the direction of the water flow. Now normally we are powering the motor through the AC mains. So it's a AC motor and it is powered through the AC main. So most of the pumps that we have in our homes are single phase induction motors. And what is there in irrigation, for irrigation purposes in agricultural fields, they are three phase induction motors. But for photovoltaic integration, what would be nice to have is a DC motor taking DC inputs and pumping the and driving the centrifugal or reciprocating pump. So let us say we have a PV module like this, and the PV module is connected to a DC-DC converter. You have the capacitor input buffer. You have a control input for duty cycle, so therefore you can always control the input of the DC-DC converter to present an appropriate input impedance to the PV panel. The output of the DC-DC converter is connected in a fashion like this to the input terminals of this motor. So what I have here indicated is the output is DC here, and then it is driving a DC motor which will drive this pump. So this is the scenario of a water pumping system wherein the source is from a PV module through a DC-DC converter. So let us see how we go about putting some numbers and see if we can design the various components of this pumping system. Consider this water pumping system. Let us say that this pump is supposed to lift water from this underground sump to an overhead tank. So let us mark and identify the various heads.